Hunt the fire fox, and your wishes will come true. Bring me the flaming fox, and I will cover you in riches. In northern Finnish folklore, a mythical animal exists, the fox of fire. It's the object of every hunter's secret dreams. Catching the flaming fox meant fulfilling one's goals in life. And anyone who could catch the fox of fire would become rich and famous. According to folklore, when an ordinary fox hair touched something, it sparked a light, but without heat. The belief is partly grounded in fact. Animal fur is able to hold some static electricity, which can create sparks in dry air. That's why the polar lights visible in northern skies were said to be created by the fox of fire. The sky lit up when the flaming fox's flanks touched trees or when his tail swept over the snow. Another old tale says that the polar lights are created by a whale living in the Arctic Ocean. Its hairy fur scales reflect the light of the sun back to the sky as flaming lights. In the Bible's Old Testament book of Job, there's a story of the mythical creature Leviathan that breathes fire into the skies. In ancient China, people believed that auroras are the fiery breath of dragons. The Finnish Kalevala, a collection of 19th century epic poetry, also describes the phenomenon of polar lights. They're said to be the gates of the north because they're shaped like arcs. In Central and Southern Europe, polar lights are very rare, which is why sighting them was connected to heavenly omens of horrors to come. Red auroras in particular were believed to warn of wars and other future disasters. Many old myths have been lost over the centuries. But the polar lights and the far north continue to arouse curiosity today. Every year, thousands of tourists travel to Lapland to catch a glimpse of the Northern Lights. People are also interested in the north because climate change is heating the earth. And snowy slopes and untouched pure nature always seem to fascinate city dwellers. Polar lights are born from the sun, our closest star. The sun emits not only light, but also charged particles. Every hour, billions of tons of plasma burst out of it. These particles are called the solar wind. The solar wind has immense power. It has shaped our solar system for billions of years. Comets get their impressive tails from the solar wind. The planet Mars isn't protected by a magnetic field. That's because the solar wind has chipped away at the planet's atmosphere, robbing it of its ability to sustain life. As for planet Earth, its magnetic field prevents the particles of the solar wind from getting close to the surface. But the solar wind shapes the magnetic field into the magnetosphere, a protective area around the planet. The electrically charged particles of the solar wind bring with them their own magnetic field. When the flow of charged particles hits the magnetosphere of the Earth, the pressure that's created stretches the magnetic field on the night side of the globe like a rubber band. The field stretches and stretches until it quickly snaps back to its original form. At that point, it catapults the charged particles towards the North Pole and the South Pole, creating polar lights. The particles originating from the Sun surge into the Earth's atmosphere from the magnetic poles in the north and south. The areas around the poles are called aurora ovals. Polar lights occur on them all the time. In Finland, statistically speaking, most auroras occur in the northern part of the country, Lapland. Clouds and snowfall, as well as light from settlements and traffic, can hinder the sighting of polar lights. In the southern hemisphere, solar activity strongly influences how often polar lights are seen. In Lapland, the occurrence of auroras is more regular. Here you can see the northern lights from August through to April. after which the increasing daylight conceals them from view. In order to see an aurora, it's best to go to an open area that's as dark as possible. You should be far away from settlements and their light pollution. An ideal spot has good sight lines to the northern horizon. In Finland, a cold, clear night is a good time to sight polar lights. For the most impressive auroras, you might need a lot of patience. And to dress warmly too. The human eye isn't very good at distinguishing different colours in the dark. That's why the northern lights look paler to the naked eye than they do in photos. The weather doesn't influence the frequency of polar lights, but because they're formed very high up in the atmosphere, they can't be seen when it's overcast. And polar lights are rarely sighted if sunspots disappear, which they sometimes do for decades. The last time that happened was at the beginning of the 19th century. Over 2 decades, only a couple of polar light sightings were recorded in the whole of Europe. How the auroras look depends on where you sight them. The most common ones above the horizon are pale and look a bit like a glowing curtain. But if you're standing right under that curtain, you experience the lights in a completely different way. Part of the curtain will fall on your left and the other part on your right. It looks as though the curtain is coming closer. This is called a corona. The crown of light stretches in different directions into the sky. After the most intense auroras have passed, you can still observe polar lights in the sky for up to 4 more hours. It's not fully known how these pulsating auroras come to be. Their creation may be linked to electromagnetic radiation at an altitude of 25,000 kilometers. One theory suggests that what are called chorus waves switch the light of auroras on and off like a light switch. Sometimes people say that as they watch the polar lights, they can hear a humming or rattling sound. It's unlikely they're really coming from the auroras, which originate at around 100 kilometers above the Earth's surface. From that altitude, sound takes several minutes to travel to the Earth, and researchers doubt sounds linked to the aurora's movements can be heard at all. One possibility is that the electromagnetic waves turn into sound waves in objects close to the viewer. These objects could even be a person's hair or clothes, or even some parts of the inner ear. The latest Finnish research indicates that these kinds of sounds can indeed occur during polar light sightings. Their causes, however, are not yet fully understood. The flames of a fire help us understand why polar lights take on different colors. Colours of flames are created in similar processes, depending on the material that's burning. Different substances have their own characteristic burning colours. Similarly, the different gases of the atmosphere create the different colours of an aurora. Polar lights have layers of colours. On the lowest layer, there's violet. The second layer is green. And the highest layer is red. The changes in colour reveal to us the layered composition of the atmosphere. The light of the auroras is created by the collision of the particles from the solar wind with the gases of our atmosphere. The molecules of the gases are charged and, like burning chemicals, light up in different colours. Purple is created by charged nitrogen molecules. The green and red seen in auroras are created by charged oxygen molecules at an altitude of about 200 to 400 kilometers. A sensitive camera lens can also detect the color blue, which is created by ionized nitrogen molecules. Sunstorms create much more than just beautiful light spectacles. A magnetic storm can be so powerful that it disrupts electric and mobile networks. The term space weather is used to describe the changing conditions of the Earth's ionosphere and the solar system, as well as the impact that could have on our daily lives. Changes in space weather mostly have to do with alterations in electric and magnetic fields. Bursts of highly charged particles in space can damage satellites and even endanger the health of astronauts. Storms in the magnetic field also release bursts of particles into the atmosphere, where, for instance, they increase the amount of radiation plane passengers are exposed to, especially on flight routes over the poles. Space storms also cause disturbances in radio traffic and GPS signals. Sudden changes in the magnetic fields trigger electric currents and electricity grids. In oil and gas pipelines, the same currents can accelerate corrosion and prevent the regular electric monitoring of it. In electricity grids, the currents can even cause large power outages and damage electricity transformers. One strong burst like this occurred in 1859. Back then, what was called the Carrington storm that broke nearly all the electrical devices. It was history's largest particle burst and created polar lights that were visible all over the globe, even over the Caribbean. These days, people are very dependent on electricity grids and satellites. A burst like this today could bring down the entire internet and cut all electricity. Our everyday life would come to a sudden stop. By the time the auroras of this kind of superstorm would light up our skies, it would be too late to try and prevent a power outage. The sun's activity is monitored around the clock to help us prepare for a magnetic storm. Once a particle burst has been sighted, around 6 to 8 hours remain before it hits the Earth. Electromagnetic bursts of such intensity are very rare. The most recent highly charged burst was in 2012, but fortunately, it didn't travel in the direction of our planet. However, there is good reason to say that the ancient myths about polar lights predicting wars and destruction may hold some truth. The Northern Lights have captivated people's imaginations and fascinated researchers for hundreds of years. Science is on the brink of finding answers to many of the questions they pose. Polar lights await deep respect in us. They remind us of the hidden powers of our solar system. The Earth is fully dependent on the Sun, a chaotic ball that generates energy through nuclear fusion. Polar lights are the Sun's touch on Earth. They directly connect us to our home star, and at the same time, auroras remind us of our insignificance in the vast beauty of the universe. Perhaps we'll never know everything about polar lights. It might be best to just admire them and let our imaginations run free. That way we might catch a glimpse of the flaming fox's tail.